everybody, welcome to Unit 6 Video 5. And so if you can go ahead and take out your Unit 6 note packet and go to number 5 here. And today we're working on I can graph parabolas in the form of x equals a, parentheses y minus k, parentheses squared, plus h. So these are what we call sideways parabolas. And if you notice, these ones here are in vertex form because it's saying x equals a, parentheses y minus k squared, plus h. And remember, hk is the vertex, so that's why it's vertex form, because you can easily identify the vertex here. All right, so with these sideways parabolas, again, you'll notice that they're sideways because they open along the x-axis. Now it says x equals. The ones we did last week were opening up and down along the y-axis. They said y equals. So here, this one, we have a positive parabola because if you were having the coordinate plane, this one is opening to the right or the positive direction. Remember, along the x-axis, the positive numbers are to the right and the negative numbers are to the left. So if you have a positive parabola, remember our focus is on the inside, or in this case, it's to the right of the vertex, and the directrix is to the left or behind the vertex. Also, HK is our vertex. It's our starting point right here. And we also remember from our upwards facing and downwards facing parabolas here, we have this distance is C, right? From the directrix to the vertex, and then from the vertex to the focus, it's that same distance. It's also called C. Remember, the focus to the vertex and the vertex to the directrix, they're equidistant, so they're the same value. All right, on this right-hand side here, this one is a negative parabola because, again, if you have your coordinate plane, the x-axis, the positive numbers are to the right and the negative numbers are to the left. So this parabola is opening towards the negative directions, or it's opening along the x-axis towards the negative numbers. Okay, so let's go ahead and graph our parabola. And remember, when we start with the parabola here, you need to always start by finding the vertex. And so remember, the vertex is HK. And these parabolas here are in the form of the vertex form. So, but this time here, since it says x equals, k is on the inside of the parentheses and h is on the outside. So if I look at my equation here, I have 2. So that means this is going to be h. And then on the inside, it's y minus k. So since this is y minus 5, that means 5 is k. So I'm going to go ahead and put that on my line down here in coordinate form. So my vertex is 2, 5. And remember, this one is a positive 5 because this is saying y minus 5. And the original form is y minus k. In order for it to be a negative 5, then this would have had to say y minus a negative 5, which would have been y plus 5, okay? So here, it's 5, not negative 5. All right, let's go ahead and start by plotting our vertex. So 2, 5. So we're going to go ahead and plot that first on our graph. So 2, 5 is right here, okay? So there's our vertex at 2, 5. So now that we have our vertex, we can go ahead and sketch our axis of symmetry. So now our axis of symmetry, we know these are going to open to the right or to the left, which means now our axis of symmetry is going to go through the y-axis. Look at this. It's going to cut your parabola in half. And so since this axis of symmetry is cutting through the y-axis, it now cuts through, it makes a horizontal line. So since it goes through the y-axis, we want to say that the axis of symmetry is y equals 5 because it's a horizontal line that's going through the y coordinate of the vertex, okay? So y equals 5. And since it's a line, you have to write y equals 5, not just the value of 5. All right, so let's go ahead and start finding our focus and our directrix. So in order to find the focus and the directrix, we need to know that C value, because remember that C value is going to tell us how far away the focus is and how far away the directrix is from the vertex. So in order to find C, remember again, we have a similar equation. A is the coefficient of the quantity that's being squared, and A is equal to 1 over 4C. So in this equation down here, we have 1/12. So A equals 1 over 12, which is equal to 1 over 4C. And so now that we have this proportion, we can go ahead and solve it. Remember, to solve proportions, you cross multiply. So we get 4C equals 12. We're going to divide each side by 4. And so we get C equals 3. So we need to go 3 units away. Since this parabola here is positive, it means it's going to open towards the right to all the positive directions along the x-axis, which is to the right of 0. And then remember, to the left of 0 would be negative. Okay, so our focus is on the inside. So we need to start at the vertex and go to the right 3 units. So here I'm at the vertex. So I'm going to go to the right or the positive direction 3 units because my focus is on the inside. So 1, 2, 3. So at this point right here, I want to write down that coordinate pair. So this is 5, 5. So my focus is at 5, 5. And if you want to, you could put a little F next to it if you want, just to mark it. Same thing with the vertex. If you feel more comfortable putting a little V here, put a little V. All right, now we need to find the directrix. So the directrix is going to be the vertical line behind your parabola. And again, it's C distance away or C units away. So since C is 3, I'm going to start at my vertex and I'm going to go to the left 3 units. So 1, 2, 3. And then at this point, I'm going to draw my directrix. And remember, my directrix is this vertical line behind your parabola. So since it's a vertical line, we need to write the equation of this line. So the equation of this line would be x equals -1, because it's cutting through at -1. Remember, we could have also done it mathematically. If here you're on the vertex, we're moving along the x-axis. So to find the focus, you could added 3 units to the x value. So 2 plus 3 gives you 5. So that's where I'm getting 5, 5. And same thing here. You're going along the x, so we could subtract 3 units from the x value here. So 2. So 2 minus 3 is how I'm getting -1. So you can also do it mathematically. All right, so we just need to sketch this. We're not concerned with the actual points here. We're just concerned with where if it's open to the right or to the left. But since I do know that it's a fraction, 1/12, it means it's going to be a wider parabola. So I'm just going to go ahead and sketch a wide parabola like this. And it would open again to the right because we know it's positive. So now we need to talk about the domain and range. So remember, our domain is all of the possible x values, meaning if you plug in a value for x, will you get out a value for y, or a real number for y that you can plot. And so if we look along our x-axis, if I look here along the y-axis, when I'm on the x, if I look along the y, there's no values over here yet on my parabola. So the first value along my x-axis is right here. And then if I look, let's keep going on my x-axis, looking along the y, I notice I start to get values on the y-axis that are on this parabola. So that means my domain starts here, and it goes everything to the right. Well, here is 2. So along the x-axis, you're at 2. So it's included as a solution. So we say bracket 2, and it's everything to the right. So to infinity. Okay. Now the range is the y value. So now we're looking on the y-axis. And we're saying if I plug a number in for y, I'm going to get out a number for x along this x-axis here. And so if I look along the y, it is. Since this parabola is opening along the x-axis, that means anything I plug in for y, I'm going to be able to graph a coordinate for x. So that means my range here is -infinity to +infinity. So if you notice, these are kind of opposite of the ones, the parabolas where it says y equals. When we talked about ones that go up and down, the domain was all real numbers and the range you had to find. But now, since this one is opening along the x, they've switched. Now the domain you have to find, but the range will always be all real numbers. Okay, let's go ahead and take a look at a negative parabola. So here we have x equals negative 1/16, y plus 3 squared minus 4. All right, so again, we know that this is in vertex form. So if you want to take a look at vertex form again, the general equation is right here. And we need to go ahead and start by finding that vertex, hk. So again, hk. So h is this value that's on the outside now, and k is on the inside, because remember, k goes along with the y value. It's the y value of the vertex. So this is our k value. But here you have to be careful, because remember, the general equation for h is plus h. Well, since this is a minus 4, this is like saying plus a negative 4, which means h is negative. So it's negative 4. And then here, k, since it's y plus 3, and we know the general equation is y minus k, that means in order for that to be plus, it has to be a minus 3. So it's y minus a negative 3. So this is negative. So I get negative 4, negative 3. All right, so let's go ahead and start by plotting our vertex. So negative 4, negative 3 is right here. So we have negative 4, negative 3. And again, if you want to write that a little v just to help you remember, go ahead. You can put a little v there for your vertex. So now we need to go ahead and find our axis of symmetry. So since these open up along the x-axis, that means the axis of symmetry cuts through the y value of your vertex, and it's going to give us this horizontal line. So since it's going through the y value, making that horizontal lines cut through the y-axis, that means this axis of symmetry is y equals negative 3. All right, so now we need to find the focus and the directrix. So the focus, since this parabola is negative, we know it's going to open up along the x-axis in the negative direction. So it's going to open to the left here. So we want to go ahead and find that c value. So I have negative 1/16 equals 1 over 4c. I'm going to cross multiply. So negative 4c equals 16. Divide by negative 4, divide by negative 4. So c equals negative 4. But remember, it's a distance, so we're taking the absolute value. So we get c equals 4, okay? So we're going to go 4 units. So here's my vertex at negative 4, negative 3. I know this is negative, so it's opening to the left, which means my focus is going to be to the left of my vertex here. So I need to move over 4 units along the x-axis. So 1, 2, 3, 4. So right here is my focus. So again, if you want to go ahead and put a little f there, you can. And we always write the coordinate. So the coordinate is negative 8 minus 3. So we went 4 units. And now we need to find our directrix. So this means our directrix will be to the right of our vertex. And again, we're going to go 4 spaces. So this is 1, 2, 3, 4 right here. And so this one happens to be along our y-axis. So since it's along the y-axis like here for our directrix, then we're going to say that the equation of this vertical line is x equals 0, because it's on the axis itself. X equals 0. All right, so now we need to go ahead and do our sketch. Again, we know this is negative 1/16, so it means it's going to be a wider parabola. So it's going to something like this. So here's our general sketch of our parabola. And now we need to go ahead and find our domain and our range. So the domain is all of the x values. So again, if you're looking along your x-axis, you're saying at what point am I getting y values? And so all along here, remember, we always read negative to positive, so left to right. So here I'm getting numbers along my y-axis, my x-axis, I'm getting numbers. But then after the vertex here, I don't have any other points. So that means my range, or I'm sorry, my domain, if I look on my x, goes from negative infinity, because it started here on the left in the negative direction, and it stops here. And that's at negative 4 along the x. And remember, it's included as a solution, so it's negative infinity to negative 4. And then again, if for our range, if we look along the y-axis, they have, if you're plugging in values, you're getting out values for x, since these go into infinity. So it means you're always going to have this value. So the range is negative infinity to positive infinity. So all real numbers. Okay, and one thing again about, remember the C value, I just counted the 4 units to the left and 4 units to the right, but you can also do it mathematically. So if you're here at the vertex, you're moving along the x-axis. So if you're at -4 and you're going to the left or -4 direction, then that's where I'm getting -4 minus 4 gives me the -8. And if here you're at -4 and you're going to the right or plus 4 units, -4 plus 4 ends up at 0. So that's also where I'm getting x equals 0. So just again, you can do it mathematically. All right, let's go ahead and go to the next page. Okay, so for number 3 here, again, we have these sideways parabolas. So remember, we need to get them in the form of the vertex form. And so we need to go ahead and write down, you can write it down if you don't remember what it was. We want it to say this: x equals a, parentheses, y minus k squared plus h. So we want to, we want to go ahead and write this: x equals a, parentheses, y minus k squared plus h. So this is in vertex form. And so right now these are not in vertex form, but we need to make them in vertex form. And again, remember, in order to do that, we can complete the square. So this time, since I have y squared and y, I want those two on the same side, and I'm going to move everything else to the other side. Since this y squared is already positive, I'm going to leave it where it is. So I get y squared minus 2y, and then I'm going to go ahead and put a little blank spot because I know eventually I have to complete the square. And I'm going to add the 12x over, so you can add 12x. So add 12x, so 12x here. And then you are going to go ahead and subtract the 25. So subtract the 25, so minus 25. And you can go ahead and put another little blank spot. All right, so because this is quantity squared here, we know we have to complete the square. So I'm going to take half the coefficient of y, so that's going to give me a -1. And I'm going to square it. So remember, when I do that here, I'm going to get a +1 and this blank. So then I need to complete the square. So I get y minus 1 squared equals, on the right hand side, I have to combine these like terms. So I get 12x minus 24. All right, and so now that I have this, remember, I'm trying to isolate x so that it's in the vertex form here. So now I'm going to add the 24 back to the other side. I'm going to add 24. So I get y minus 1 squared plus 24 equals 12x. But remember, we're trying to isolate x. We want x all by itself, which means now I need to divide all these terms by 12. And yes, I'm dividing this by 12, but remember, there's an implied 1 in front of here. Okay, so when I simplify this, instead of writing y minus 1 squared over 12, I'm going to think of it as 1/12 times y minus 1 squared. And then here I'm going to simplify, so to plus 2 equals x. All right, so now I have it in vertex form. If you'd rather write it with the x on the left-hand side, you can. But we can still identify the vertex. But if you want to switch the order, you can. It would look like this: x equals 1/12 y minus 1 squared plus 2. All right, so if you would just rather write it that way, go ahead and you can switch the order. All right, so what we need to do first here is, again, we always want to start by identifying the vertex. And so when you identify the vertex, remember, we want HK. But remember, in this form, h is on the outside, k is on the inside of the parentheses. So here's my h value, and then here's my k value. So since this is y minus k, and I have y minus 1, then we know right now that our k value is going to be a positive 1, and our h value, since this is plus h and this is plus 2, our h is going to be 2. So our vertex is 2, 1. So 2, 1 is our vertex. So go ahead and write that on the line, and then let's go ahead and plot that point. So 2, 1 is right here. And if you want to put a little v, go ahead and put a little v so that you know that that's the vertex. This is a positive 1/12, so we know it's going to open up to the right, so the positive direction. So that means our focus is going to be to the right of our vertex. So let's go ahead and find that C distance. So we take this A, so we say 1/12 is equal to 1 over 4C. And then we're going to go ahead and do our proportion. So 12 equals 4C. We're going to divide each side by 4. So we get 3 equals C. So we need to start at our vertex. Oh, I'm sorry, I skipped a step. I should have done the axis of symmetry first. So let's go ahead and do that axis of symmetry. Remember, it goes through, it's our horizontal line that cuts through the y coordinate of our vertex. So since it's going through the y coordinate, we say y equals 1. So it's that horizontal line through the y coordinate of the vertex. Okay, so now let's plot the focus. So since we have the distance is 3, we're going to start at our vertex, and the focus is on the inside. And since this opens in the positive direction, we're going to the right. So we're going to go to the right 3 units. So 1, 2, 3, and then we write this coordinate pair here. So we are at 5, 1. Because we went along the x-axis, we're still at 1 on the y, and went to the right 3 units. So 2 plus 3 is where I got 5. Okay, so let's go ahead and plot our directrix now. So our directrix here is we are going to go behind the vertex, and we have to go 3 units. So we're going to go 1, 2, 3. And remember, our directrix is a vertical line. So here's my vertical line. And we need to write the equation of that vertical line. So since vertical lines cut through the x-axis, and this cuts through at -1, we're saying the directrix is x equals -1. And again, you can do that mathematically. You're here at 2, and you're going to the left or in the negative direction, 3 units. So 2 minus 3 gives me that -1 here. All right, we just need to sketch the parabola. Since this is 1/12, we know it's going to be a wider parabola. So I'm going to go ahead and just sketch my wider parabola opening in the positive direction. So then let's go ahead and talk about the domain. So we're looking along the x-axis, and we're saying at which point do we start to get values along the y-axis? Well, our first point along the x is here at 2, and then if you look along your x here, everything, it keeps going on and on forever to infinity, and you're getting points along this y-axis. So that means your domain is at 2 to positive infinity. And then for our range, remember we look along our y-axis, and so for our range here, so if we look on our y-axis, we do have all these points along our x-axis. So that means our range is all real numbers, -infinity to positive infinity. Okay, so let's go ahead and go to number 4 here. So again, we need to go ahead and get this into vertex form. And because I can tell that y is squared and there's a y here, that means this is going to be a sideways parabola. X is by itself, so I need to isolate x. I want it to say x equals. I wanted to get it into this form, my vertex form. But again, I know in order to get it into this form, since it's quantity squared, I'm going to have to complete the square. So since this 4y squared is already positive, I'm going to leave the 4y squared and the 8y on the left-hand side. So I get 4y squared plus 8y. But I'm going to move the -1 and the x over. So I'm going to add 1 to each side, and then I'm going to subtract x. So I get, I'm going to write it as -x plus 1. Now I didn't put my blank spot this time because I cannot complete the square till the coefficient of what's being squared is 1. And right now there's a 4 here. So in order to make this coefficient of y squared 1, I need to divide everything by 4. So I want to divide all the terms by 4. So when I do that, now I'm going to get y squared plus 2y. Now I'm going to put my blank spot. I'm going to think of this as -1/4 x plus 1/4 blank spot. Okay, so now I can complete the square. Remember, take half the coefficient of y here, so half of 2 is 1. So plus 1, square it. On this side, I am going to write the number, so 1 squared is 1, so plus 1. So on the left, when I factor this, I get y plus 1 squared. On the right-hand side, I have negative 1/4 x, and these two I need to add. 1/4 plus 1 is going to give, remember, 1 is the same as 4/4, so 1/4 plus 1 is going to give me 5/4. Okay? All right, so now that I have that, remember, I'm trying to isolate x. I want this in vertex form, which means I need to subtract the 5/4 to this left-hand side. So I have this, y plus 1 squared minus 5/4 equals negative 1/4 x. Okay, so all I've done right here is I subtracted the 5/4, I moved it to the other side so that I can get it into my proper form. Okay, so what I need to do here is I need this x to be a positive 1x. Right now it's a negative 1/4 x. So in order to make this negative 1/4 x positive, I need to multiply by a negative and the reciprocal. So because multiplying by the negative would turn this positive, and multiplying by 1/4 by 4 will turn it into a positive 1. So I'm going to multiply everything by a negative 4 so that this can turn into a positive 1. So when I do that, I'm going to multiply it here, so this term, and I'm going to multiply it in front because remember, there's always a 1 here. Okay, so when I do that, I get, when I distribute negative 4 here, I get negative 4 parentheses y plus 1 squared. When I distribute negative 4 to negative 5/4, that is going to simplify to just a positive 5. So remember, this is saying negative 4 times negative 5 would be a positive 20 divided by 4 is where I'm getting 5. And then here, when you multiply it, you're saying negative 1/4 times negative 4, which would be a positive 4/4, which is just 1. So 1x. All right, so then again, now I have x by itself. It's in the proper form. But again, if you'd rather write it with the x on the left-hand side, you can go ahead and do that. So that's going to be x equals negative 4, y plus 1 squared plus 5. And so now it's in our vertex form. So we can go ahead and plot the vertex. Remember, hk. So this value here is h. Remember, it's y minus k. So since this is a positive 1, that means it's saying y minus a negative 1. So you have to remember your k value here is going to be negative. So our vertex is at 5, negative 1. All right, so let's go ahead and plot 5, negative 1. So 5, negative 1 is down here. And now I can go ahead and do my axis of symmetry. Remember, the axis of symmetry is a horizontal line that goes through the y coordinate of your vertex. So it's going through the y coordinate of the vertex, and it's a horizontal line that cuts through the y-axis. So it's y equals negative 1. All right, for our focus, we need to find that c distance, or the c value. So we say a, remember, in this case, it's negative 4. So I'm going to do the work, I'll do it over here. So negative 4 equals 1/4c. Remember, this negative 4 is over 1. So when I do my proportion like this, I'm going to get negative 16c equals 1. So then I'm going to divide by negative 16. So I get c equals a negative 1/16. So this is teeny tiny. 1/16 is not that far of a distance to go. But remember, when I take that c, I want the absolute value. So I'm just going to use a positive 1/16 because it's the distance. All right, so since this is a negative parabola, it's negative 4, it means it's going to open in the negative direction or open to the left, which means my focus is to the left of my vertex. And I'm only going 1/16 over. So if I'm here at 5 on the x, and I go to the left 1/16, or I subtract 1/16, that means I'd be very tiny. I can't even mark it on the graph. It's so tiny. So I'm going to the left 1/16. You're going in the negative direction, so you're subtracting. So you're saying 5 minus 1/16. So 5 minus 1/16 would leave you with 4 and 15/16 (-1). So you're right here. You just move 1/16 along the x. So your focus would be a point right here. So you're at 4 and 15/16, and then you're still at -1 on your y-axis. Okay, and now to get our directrix. So again, you're here at 5 along your x-axis, and you're going to the right, or the positive direction, 1/16 in order to draw the directrix. So you're at 5, you're going over 1/16. So now you're at 5 and 1/16, which again is teeny tiny, but we're just going to sketch a little line right here to the right of 5. So that means our vertical line's cut through the x-axis. So your directrix is at x equals 5 and 1/16. Okay, because you were at 5 and you went to the positive direction 1/16. So 5 and 1/16. All right, our domain, or actually let's go ahead and do a little sketch. Since this is a whole number, we know that this is a narrower parabola. So I'm just going to go ahead and draw a narrower parabola that would open to the left, to the negative direction. And so again, we need to look at our domain. So here along the x, if I were to plug numbers, I get numbers out along the y-axis, but then after the vertex, it stops. So that means my domain went from everything to the left here. Remember, everything to the left is -infinity, and it goes all the way to this point right here along my x-axis, which is 5. And it's included, so it's a bracket, so -infinity to 5. And then my range, if I look along my y-axis here, the range, you plug it in, you're getting numbers along the x, so that means my range is -infinity to +infinity. All right, thank you for watching the video.